Hi there and welcome again to the channel. Today we do not have a particular question from a past examination paper because we want to discuss a particular type of integral. The one that I have on the board here in blue. It's integrate with respect to x 1 over a sine of x plus b cos of x plus c. And we are going to do that with reference to a particular integral which I have in black here. It's 1 over integrate with respect to x 1 over 7 minus 3 sine of x plus 6 cos of x. Now the first thing that we want to do here is to construct a right-angled triangle. I've got the triangle here on the board. It's triangle A, B, C. And we let this angle here, angle at A, be equal to x over 2. The opposite side, let it be equal to t. The length of the opposite side is equal to t. The length of the adjacent side is equal to 1. Once we do that, we can immediately make the following deductions. Tan of x over 2 is equal to opposite over adjacent, which is equal to t over 1, which is equal to t. So straight away we can say tan of x over 2 is equal to t. Again, considering Pythagoras' theorem, in this triangle, this side squared is equal to this side squared plus this side squared. That's what Pythagoras' theorem says. So this side is equal to the root of this side squared plus this side squared. In other words, the length of this side is square root of 1 plus t squared. Remember, this side is 1 and that one is t. Okay, let's look at other trigonometrical ratios in this triangle. Sine of x over 2. Now, sine of x over 2, right? Let's write it over here. Sine x over 2. We know that sine of x over 2 is equal to opposite over hypotenuse. So it's equal to t over that. So sine of x over 2 is equal to t over the root of 1 plus t squared. Okay, what about cos of t, cosine of t? It's equal to adjacent over hypotenuse, which is 1 over the root of that. So cos of x over 2 is equal to 1 over the root of 1 plus t squared. Now, the reason why we are going through all this is because we want to end up with a substitution that gets rid of sine of x and cos of x. But of course, once we substitute this cos of x with another variable, we also have to change our variable of integration. So the whole process is about changing this and that and that. Now we have found what sine, well, we haven't really. We have found what sine of x over 2 is and cos of x over 2 is. But now, this is expressed in terms of sine of x and cos of x. So we need to change sine of x over 2 or express sine of x over 2 in terms of sine of x. We know from double angle formulas that our sine of x is equal to 2 sine of x over 2 cos of x over 2. When we do the substitution, remember our sine of x over 2 is this, our cos of x over 2 is that. So this is equal to 2 brackets t over root of 1 plus t squared brackets 1 over the root of 1 plus t squared. It's fun, isn't it? Okay, so there we are. We can simplify this. We know that when this squares itself, the square root sign disappears and on top we've got a 2t. So finally, sine of t is equal to 2t over 1 plus t squared. Okay, maybe let's book this across there so that we have the value when we want it at some point. We're going to need this at some point. Right, so we have discovered that our sine of, let me just do it like this so you can see what I'm writing. So sine of x, sine x is equal to 2t over 1 plus t squared. Okay, right, let's deal now with cos of x. Cos of x, we know that using our double angle formula, cos of x is equal to cos squared x over 2 minus sine squared x over 2. Substituting these values, we have cos of x over 2 of x over 2 is this. So we have 1 over the root of 1 plus tan t squared, all squared. Remember, cos is squared there, minus this here squared also, which is t over the root of 1 plus t squared, all squared. Can you see that? Okay. Let's simplify. This becomes 1. This one squared becomes just 1 plus t squared. So this is 1 plus t squared. And here, same story, but the t is squared above, so it becomes 1 t squared over 1 plus t squared. They have the same denominator, so it just becomes 1 minus t squared over 1 plus t squared. That is cos of x. Let's book it over there. I always have to jump over my line there. So we said cos of x is equal to that. So let's book it down here. Cos of x is equal to 1 minus t squared over 1 plus t squared. All right. Now, we've done that. We've done this. Now we need to handle this guy. Because at the end of the day, when all is done, everything about x will be gone. Right. So let's see how we can get our dx eliminated. Okay. This, we're done with it, so we can clear it. Right. Remember we said t is equal to tan of x over 2. So t is equal to tan of x over 2. What is dt dx? Dt dx is equal to half of sec squared x over 2. Remember, tan of, when f of x is equal to tan of theta, f prime of x or the y dx, if you like, is always equal to sec squared theta. So here it's tan of half x, so dt dx will be half of sec squared x over 2. But what is sec squared x over 2? Sec squared x over 2, so we can write this as half, bracket, this is equal to 1 plus tan squared x over 2. So this is 1 plus tan squared x over 2. Okay, from our trigonometrical identities. But what is tan of x over 2? Tan of x over 2 is equal to t. So this can be written as 1 half brackets 1 plus t squared. Right? Remember, this is dt dx. So let's write it over here. dt over dx is equal to half of 1 plus t squared. Let's just make sure we get this right. T is equal to that. So dt dx is half 6 squared x. But what is half 6 squared x? It's half of 1 plus tan squared x over 2, where our tan of x over 2 is equal to t. So that takes us here. Now, let's simplify because we want to express everything, express dx in terms of all this. So we can cross multiply. We have our 2 dt when I multiply by 2 and I divide by 1 plus t squared. I hope I'm not blocking your view. 2 dt, 1 plus t squared, I've divided over here. That gives me, and my dx goes that side. This is equal to dx. Again, let's book it over there. I think now we are in business, aren't we? Because now this is done, that is done, that is done. So our dx is equal to 2 dt divided by 1 plus t squared. Okay? So here are the 3 equations that are going to help us along the way. Right. Now we are ready for the actual substitution. Okay, let's write our integral nicely over here. This is where we have to kind of slow down a little bit because the algebra is a little bit heavy, and if we are not careful, we lose it. So let's write, as you can imagine, let's write, here is our integral here, dx, and over here we have 7 minus 3 sine of x plus 6 cos of x. Okay. Now, what is our dx? Our dx, we have calculated, is 2 dt over 1 plus t squared. So this is equal to the integral of 2 dt over 1 plus t squared. But this is all divided by this. So somewhere here, downstairs, we have, of course, 7 there, minus 3. What is sine of x? Sine of x is that one there. So it's now in brackets, 2t over 1 plus t squared in brackets. Then you have a plus 6 cos of t, which is cos of x, 6 brackets. What is cos? It's 1 minus t squared over 1 plus t squared. You see, the algebra, what is now left is the algebra to deal with. So that's why I said we've got to slow down a little bit, because if we trip, that's it. We are finished. All right. Let's first of all deal with everything downstairs here. We can put everything under one common denominator. Here it's 1 plus t squared, 1 plus t squared. So we would need to put our 7 under the same denominator. So we write our integral again here, 2 dt over 1 plus t squared divided by, when we put 7 under that, we have to multiply it by that, so it becomes 7 plus 7t squared. Okay? Then here we are multiplying there, that's 3 times that, which is minus 6t. Here we get a plus 6 minus 6t squared. All this over 1 plus t squared. Okay, let's look at it before we proceed, just to make sure all is well. So we put everything under one common denominator. This was over 1, it's now over that, so we must multiply it by 1 plus t squared. So there is our 7 plus 7t squared there. Here is our minus 6t. Here is our 6. Here is our minus 60 squared. Looks okay. So we can come down here and simplify the top here. So it becomes 2 dt over 1 plus t squared. Then we put our big dividing line there. This is 6. Now we have 7 plus 6, which is 13. Then we have 7t squared minus 6t squared. It's 1t squared. Then, of course, we just have a minus 6t. This, remember, it's over 1 plus t squared. Now you have this over 1 plus t squared and this over 1 plus t squared. So the 1 plus t squared will cancel out here and there. We are left then with the integral of 2 dt over, I'll write it as t squared minus 6t plus 13. Let's breathe for a moment and take a look at what we've done so far. Okay, we came here, we started substituting, this becomes that, 7 there, this is replaced by the value of sine of t, this is replaced by the value of cos of t. We found a common denominator, we multiplied this 7 by our 1 plus t squared, everything else remained the same. Then we came here, we simplified everything, added like terms together. We ended up with t squared plus minus 6t plus 13. But there was this one here down here and that one there up there. So these two cancel out and we remain with 2 dt over t squared minus 60 plus 13. Still, we got a problem here. All right, but it's doable because what we want to do now is to make this a perfect square. In other words, to complete the square here. Because we can't factorize. If we could factorize it, we could have broken it down into partial fractions and integrated the two fractions separately. But you can't factorize this. So we need to complete the square. Right, let's clear this and complete the square. I'll bring this up there so we can bring our working down towards the bottom here. So we have here now, here's our new integral. It's 2 dt over t squared minus 6t plus 13. Right. How do we complete the square? Let me write it here, 2 dt there. It's t minus 3. You divide the coefficient of t by 2, then you square this. But when you have done this, remember, if I open up the brackets, I'll get my t squared, and I'll get my minus 6t, but I'll get a 9 from the 3 squared. And when I then add it up with 13, it's now something which we didn't have. So we need to subtract the 9 that I get from the 3 squared. So it becomes 13 minus 9. Let's write it like that. So minus 9 plus the 13 that we already have. And this, of course, becomes, let's write it down here. It becomes the integral of 2 dt over t minus 3 all squared. Now, 9 minus 9 plus 13 is 4. And let's write this as 2 squared. Okay, so now we have the sum of two squares. Let's write it again as taking the 2 outside. It's 2 integral of dt over t minus 3 squared plus 2 squared. This reminds us of a certain standard integral. We know that, let me just put it over here. We know that when we have the integral of dx, or let's say dt, of a squared plus t squared, it integrates to 1 over a arctan of t over a plus c, of course. So let's identify the terms here. Our t here is t minus 3. Our a is 2. So this integrates to, remember we have a 2 there. Let's put our 2 in outside the bracket. So there we are. This integrates to arctan. We have to divide by a here, but our a is 2. So it becomes half arctan. What is our t there? It is t minus 3, and we must divide that by 2, of course, plus our c. Okay? Of course, this 2 and that 2 will cancel out. So let's simplify that. It becomes arctan of t minus 3 over 2 plus c. But what is our t? Our t is equal to tan of x over 2. So we can write this as, this is equal to arctan of bracket tan of x over 2 minus 3, all this divided by 2 plus c. Take note of the way we have substituted for t there. Remember, this is t minus that, but this t is actually tan of x over 2. So this was arctan of that. So the arctan is outside, but then inside here we have t, which is tan of x over 2 minus 3, and it's supposed to be all of them divided by 2. So that's the expression we have here. As you can see, this is quite involved in terms of the algebra. So, but the method is pretty simple. You make these substitutions, you draw your nice little triangle there, let this be x over 2, let this be t, and that be 1. Then from there, you can make these deductions. It follows that tan of x is equal to, x over 2 is equal to that, and this is equal to that. And then when you find your sine, you can express it, your cosine, and then remember also to try and find dx in terms of your dt and t, which is what we did. Once you have done all this, you can just come to your integral. It doesn't necessarily have to be that. It can be something else. But you come and then you plug in your values of sine of x and cos of x and dx, and the real algebra starts here. This is perhaps where one has to be pretty careful. Otherwise, you might lose mark because of making a simple and stupid mistake when all the way you had got everything right. Next time, we will look for a problem from a past examination paper and create a video for it. Till then, bye-bye, and please subscribe.